Welcome back. So I bought a kit for a tool and cutter grinder, and I'm slowly working through the machine and building it the way I want and need it. And one thing that really annoyed me are the graduations on all the accessories. All the accessories have adjustments for angular settings, and the original engravings are just done on this thin aluminum sheet metal, and they are just riveted on with those rivet nails. And obviously precision that you could expect from this is something in the realm of plus or minus 5 degrees. So not exactly what I'm looking for. So I chiseled these off and I machined a round reference surface on. This is the base of the motor driven workhead. I machined a round reference surface on the rotary table, just with an end mill all the way around, and then I used the milling machine to shape plus minus 90 degree markings on there, and then I took the whole setup over to the engraving machine and I cut the numbers. And I was thinking that this might not be so interesting, but I was told on Instagram and Facebook that people want to see this, so here we go. Obviously this is a different part. This is the elbow between the base and the actual dividing head that you use for normal standard tool and cutter grinding. And this also had a plus minus 40 degree graduation nailed on here. I think it was this one. It was on here like this for the tilt of the workhead. This is normally 90 degrees that direction, and this is for the tilt of the spindle. So to start, I have to align the surface with the travel of the machine, and now I'm just manipulating the rotary table until I get from here to here a 0 reading. Let's zero this out. It's still rising, so we adjust it a little bit. Okay, we got 0 here, and when we traverse over, it starts to rise a little bit to the end, but that's not very concerning. Our dial here shows us 175 degrees, and we write that down because this will be important later. 175. Also, when I do something like this, where I only have to jump a few holes, I don't like to use the sector arms here on the index plate. They just get in the way. I like just to mark the holes that I use. 1, 2, 3, 4. This is a 16-hole bolt circle, 16-hole index circle. That means with a 90:1 ratio on the rotary table, I need to go 4 holes for 1 degree. That means here 1, 2, 3, 4. 4. That gives us our 4 positions. That means for 1 full revolution we get 4 degrees. And that's easier than to fumble around with the sector arms for each division, especially when we have to do so much lines. Let's go back to 175. Keeping the backlash in mind. I also like to mark the direction that I'm cranking. Next will be to center the spindle over the central bore of this casting, and to start with we can just rough align it with the OD of the spindle just to get an idea where we are, like this. Then we can bring in dial test indicator and sweep the bore. Okay, now I'm just sweeping the bore. Get 25 here, get 20 here, a little bit to the left. Yeah, we are within 0.02 millimeters. 0 out our 0. 175 is our 0. 175 on the rotary table is our center, so it's 0. I want plus minus 40 degree on the dial, and when I machine the reference surface, I want the reference surface to be a little bit wider so it doesn't look as cramped. So we'll go 45 plus minus. Minus 45 plus 45. 130 and 220. So we have to machine from 130 to 220. And we're going to use a ball nose end mill 6mm 2-flute carbide, because the what do I call it? The ball nose blends nicely from the cast iron into the paint. So on these vertex rotary tables, there is on the index arm there is a set screw here. You can here, when you open that one up a little bit, you can move and remove the index pin, the spring-loaded index pin. And I pulled it just a little bit back so I can hand crank the rotary table without having to remove the index plate and the index pin here. So 130 on the rotary table here, that's our starting position. Then we will move in with the X travel of the table and crank our rotary table until we hit 220, and we're done. We're machining cast iron, Bondo, or so whatever they use to fix the castings, and paint, which is probably leaded. So dust extraction is a very good idea here. Okay, I put one of my older Mac bases here on the table and I Y-script the shop vac hose to it. So as you can see, it cleaned almost up. I have a little spot here from the rough cast surface below the Bondo and paint. And you can also see that the ball nose end mill, it not only blends the cast iron, but it also makes a nice transition to the paint and the Bondo layer. So also there is no space to catch dirt now. And it's also not a sharp edge, and it's just looking nicer. I will take one more pass and I guess this will clean up. Okay, this is the tool we're going to use. This is a boring bar holding a high-speed steel tool bit in here, which is ground to a V shape with a tiny flat on the tip so it's not as fragile. And it's cutting like this, like a slaughter. This will be held in the spindle of the mill. I put my tool in position, set my depth stop. I will start by cutting the longest lines, which are 10-degree increments. But first we need to set our depth of cut. There we go, 0. Now we move in 0.1 millimeter. There we go, first line. Could be a little bit deeper. Yeah, I like that. First line cut. Let's index 1, 2, 3, 4, 5, 6, 7, 8, 10. And cut the next one. There we go. That's 0, 10, 20, 30, 40 degree. Okay, I cut also the minus increment. Now we change our depth stop for the 5-degree lines. There we go. Now we can change the depth stop one last time to cut the 1-degree marks in between. And last line. Done. Okay, the slotting tool left a little bit of a burr, so normally I would check the part up in the lathe and just touch it up with a lathe file and some emery cloth, but in this case obviously it doesn't work because it would hurt. So I'm just using a stone. Followed by a small piece of 400 grit emery cloth. There we go, that's our graduation. Now we can take the rotary table with all the setup on it over to the engraving machine and cut the numbers. Okay, it's already clamped down. Not fully, but so it doesn't fall over by itself. Now I need to align it with the travel of the table with this face here. Let's push down this cover so we have a nice machine surface where we can clamp our indicator. Bring in the indicator. There we go. That's within 1/100th of a millimeter side to side. That's good enough for an engraving, especially as we're only engraving on a very short section of this part. So it's okay to get a little bit sloppy here. Get our cover back in. Okay, once again, problem of setting up an engraver precisely. I have my number template down here. Right now it's a 0. When I go on, I will change them out again against 10, 20, 30 and 40. And one row up in the template table I have just a blank piece of template material with a center drilled into it. And this is in line with the center of the template up here. It's just with a square aligned. And I put the stylus of the pantograph in the center hole here. And now when I move my table in the Y direction, it stays always in this line. And now, as I have my X orientation according to the template, I can move the table right and left until my ball end mill. I'm going to engrave this with a 0.8mm ball end mill. I can line that up with the 0° line. That just use a magnifier to get it very close. You can get this within 0.05mm without a problem, just eyeballing it. And now I'm just checking for clearance if I get my number that I want to engrave in here. And I can move my Y-axis on the XY table of the engraver to position it like I want. From now on I do not touch the X-axis anymore. I do not want to move the table side to side for any reason. I locked the axis and pulled off the hand wheel so I do not bump it accidentally. And I can start to engrave it. Okay, let's start by engraving the first number, which is in this case a 0. Okay, looks pretty decent to me. Now we can index our 10° increments and engrave the remaining numbers. Okay. There we go, that's our 10°. And up here we change our templates, or in this case we add one. We add a 1. So we get our we get our 10 degrees. And I align them so the split line between the two separate templates is right on center line with with my 0 mark. And we're good to go. And yes, we're engraving on a curved surface. And we could make the machine follow the radius by putting a negative of the surface above the spindle, and then the spindle will follow the curvature. But in this case it's not necessary. We are engraving on a very narrow area, and the curvature is relatively large, so it shouldn't be a big deal. If we see that the engraving on the extreme outside of the numbers gets a little bit faint, I have still my fine adjustment up here that I can use to adjust manually, just by eyeballing. Needs a little bit of experience, but works quite well. I kind of put the workhead back together without fasteners. This is just stuck on. There's a boss in there and a bore slips together. I deburred the engraving with some 400 grit emery cloth, and then I hit it with a small buffing wheel and some polishing compound. Hope you enjoyed this. Thank you all for watching, and see you next time.